All right, here are quiz 4 solutions for Math 211. A couple problems on this one, or a couple sections, I guess. First one deals with writing numbers in different bases. So we got three parts here, A, B, and C. Part A gives you the number 2,410 and asks you to write it in base 5. So what you need to know about base 5 is that we don't have a ones place and a tens place and a hundreds place and so on. We have a ones place, a fives place, a 25s place, and so on with powers of 5. So we can start to lay these out kind of in a table here. After 625 would come 3,000 some, 3125, I guess, which will be larger than we need because our number is only 2,000. So really, to put it in the parlance of the problem we did in class, I'm walking into a donut shop. I want to buy 2,410 donuts, and these are the box sizes, and I want to buy boxes as large as possible. So you don't want to buy any boxes of size 3,125 because that'd be too many donuts. You only need 2,000. But you want to buy some boxes of size 625. How many? Well, let's see. 4 of these would be 2,500. A little bit too many. So I guess I can only buy 3 of these. And 3, that's not a 3. 3 times 625 accounts for 1,875 donuts. So I kind of start out with 2,410 donuts, and if I subtract off the 1,875 that I just bought with these 3 boxes, what I have left is 535 more donuts. So then I go on to my next box, boxes of size 125. See, 4 boxes of size 125 is exactly 500 donuts. So I'll put a 4 here. 4 times 125 gives me 500. And so I can kind of subtract that from my running tally over here. 535 minus 500 leaves me with 35. So I want 35 donuts. I guess the way I could do that is by buying 1 box of 25 and 2 boxes of 5. This gives me 10, and another 25 gives me 35. I don't want any single boxes. So this would end up as my answer. I would have 3, 4, 1, 2, 0. Is the way I write this in base 5. Not 34,000, but 34120, because 1,000 implies you're in base 10. But whatever, write something like this for your answer, and you're good. Then you come down to part B here, and you're like, whoa, it's the exact same question. Well, not quite. Here I am telling you that you bought 2 boxes of this size, 4 boxes of this size, 1 of this size, and 0 singles. And I'm asking you how many donuts you walked out of the store with. Up here, the number starts out in base 10, and you're giving it to me in base 5. Down here, the number starts out in base 5, and you're giving it to me in base 10. So I'll set up the same chart. Here, since I have 4 digits, I know exactly how many columns I need to make. I got the 1s, the 5s, the 25s, and the 125s. So I take this number, 2410, and what that means is 2 boxes of size 125, 4 boxes of size 25, 1 box of size 5, and 0 singles. Well, 2 boxes of size 125 gives me 250. 4 boxes of size 25 gives me another 100. 1 box of size 5 gives me 5. And 0 boxes of size 1 obviously gives me 0. And if I sum up these numbers, I get, what, 355? And so that would be my answer up here. Part C here. Now we're going from base 3 to base 9. You could, maybe I'll write this, could go through base 10, or you could use our shortcut. So anytime you're converting from one base to another base when neither of those are base 10, one option you have is take this number, change it into base 10, figure out how many donuts this represents, and then figure out how to buy that many donuts in a base 9 donut shop. You could do that. There's a shortcut anytime you're dealing with 2 powers, or with 2 bases, and one is a power of the other one. Note that 3 to the second power equals 9. So that gives me a shortcut. Really what's going on here is in base 3, my options are boxes of size 1, 3, 9, 27, 81. How many do I want? 6. 1, 2, 3, 4, 5, and 243. Here are my first 6 powers. I guess, to the 0 power. So this is 3 to the 5th power of 3. And then the number that I'm given in base 3 is 1, 2, 0, 1, 2, 1. But the realization that you might make is that all of our options in a base 9 shop, namely single donuts, boxes of size 9, and boxes of size 81, and I guess I could go bigger, but I won't need to, are also options at your base 3 shop. So really all I got to do is figure out how many single donuts do I have. Well, single donuts are going to come from this box and this box. So I have 2 boxes of size 3, which is 6 donuts, and 1 more box of size 1. So I get a 7 over here. Maybe this should be in red to color code this. And where that came from is 2 times 3 plus 1 times 1. It's the 7 right here. And you can do that same logic on the rest of these guys. A box of size 27 is really just 3 boxes of size 9. So this 0 right here really means 0 of these 3 boxes of size 9 plus 1 for this one of these 1 boxes of size 9. So what that gives me when I multiply this out is 1, specifically 1 box of size 9. And with 81, well, let's see, I have a 1 here in size 243, but that 243 is really just 3 boxes of size 81, which is what I'm interested in down here. So I get 1 box of size 3 boxes of 81, and then I get 2 more boxes of size 1 box of 81. And if I multiply those together, 3 and 2 more gives me 5. I get a 5 right here. And so if you do the shortcut, what you'll get for your answer is 5, 1, 7 in base 9. There's the 5, there's the 1, there's the 7. And that's quicker than just going through base 10. Now you're given a completely different topic here, relations. And so you're given these different relations, and you're asked, is the relation reflexive, symmetric, and transitive for each of them? So for this first one, is it reflexive? No, it's not reflexive. And one way you could say that is 2, 2 is not in R. This element is not in my relation, R1, I guess I should say. And to be reflexive, it needs an arrow from 1 to 1, 2 to 2, and 3 to 3. It's missing 2 to 2. It's not reflexive. Maybe I should do reflexive for all of them. What about R2? Nope, that's certainly not. Why not? Well, 1, 1 is not in there. What about R3? It's got 1, 1, 2, 2, and 3, 3. So, yep, it's reflexive. How about this way? A is in R for all elements A in my set. You don't have to write it in exactly this way, but somehow convey that idea. What about R4? Well, it's got 1, 1, it's got 2, 2, it doesn't have 3, 3. So the answer here is no. 3, 3 is not in R, I guess R4, and this was R3 up here. Okay, what about symmetric? Well, the idea for symmetric is anytime you have an arrow, there must also be an arrow going in the other direction. So I have 1 to 1, the other direction would be 1 to 1, nothing to check there. I have 1 to 2, so I must have a 2 to 1. Oh, I have it right here, 2 to 1. 2 to 1, so I must have 1 to 2. Good, I have it right here. 3 to 3, nothing to check because you already have the 3 to 3. This first one is symmetric. Yes. For every A, B in R1, there is a BA in R1, therefore it's symmetric. What about R2? Nope. Got an arrow from 1 to 2, but don't have an arrow from 2 to 1, for example. No. 1, 2 is in R, but 2, 1 is not in R. What about R3? Well, let's see, 1 to 1, 2 to 2, 3 to 3, yep. Yes. Same logic as R1. What about R4? Well, let's see, 1 to 1, 1 to 2 has a 2 to 1, that's good, 2 to 2. 2 to 3 has a 3 to 2, that's good, yes. Same logic as R1. Finally, transitivity, the hardest one here. The idea with transitivity is if you have an arrow from A to B and then another arrow from B to C, you must have a shortcut arrow, one that goes directly from A to C. So transitivity, let's see here. This first relation, R1, is not transitive. And the reason why is there's an arrow from, here's the picture that we did in class. There's an arrow from 2 to 1 and an arrow from 1 to 2, but there is not an arrow from 2 to 2. So this relation is not transitive. What about R2? Well, let's see, there's an arrow from 1 to 2 and an arrow from 2 to 3, but there's no arrow from 1 to 3. There's an arrow from 3 to 1, but that doesn't help you. This is another no. There's an arrow from 1 to 2, an arrow from 2 to 3, but there is not an arrow from 1 to 3. What about R3? Yep. For every A, B, and B, C in R3, there exists A, C. You probably won't use this exact language, but that's the idea. What about R4? Okay, so this one's kind of tricky to check. One of the arrows that's missing here is the arrow from 3 to 3. Maybe we can exploit that. Is that the one most people will probably pick on? No, I think what most people probably pick on is there's an arrow from 1 to 2 and an arrow from 2 to 3, but there's not an arrow from 1 to 3. So no. There's an arrow from 1 to 2 and an arrow from 2 to 3, but there is not an arrow from 1 to 3. And maybe I'll write counterexamples may vary. No, I won't. I'm going to leave it just like that. Your counterexamples might vary. Like in this last one, for example, you could have said there's an arrow from 3 to 2 and an arrow from 2 to 3, but no arrow from 3 to 3. That's perfectly good justification for why it's not transitive. And that's the end of this quiz. I'll stop this video here.